Alright, let's give it a few minutes. Please go away, thing. There we go. Sometimes that thing never goes away for like an entire game and it blocks the board and it really sucks. Oops. You're right, it's a bluff. This is good, this is good. I got him thinking a lot, so might still win on time. That side's open, pawn. Pawn. Okay. There we go. All right. Give it another minute before we get going. Gonna write down some notes about things I've been noticing with this current pass. Before I start the stream official, I do want to go do one other thing. All right. So last time, I was checking off things from my first pass to-do list, which is buried a few pages back in this notebook by this point. And the last thing was brain scripts. I've done a first pass at the sim entities. I've done a first pass at tile scripting. So the only piece left from the design that I haven't even put a prototype in for, I haven't even done a first pass on yet, is that brain script. So let's go and look into that. There's a couple of different places where I could imagine starting this. So for one thing, we had here, before we had tile scripts, we just had the effect written right here directly. Now we have no brain scripts, but we're using the tile by going grab the ID of the thing and then, we say use, and that uses it. And so the tile scripts then tell it what to do depending on whether it's a protect or an attack that gets used. So this is what a brain script looks like. And I want to basically be able to say something like, as we're going, we're going to look at each character and say, RPG run brain context character, like that. Something like that wants to happen. Of course, there might be more of the combat context, like the enemy party and stuff, that needs to get into the brain. And there's another thing which happens here, which is that sometimes what I actually want to do is RPG run brain context party. That's actually all I want to do. We get rid of the other party part and just say run the brain on. Well, I guess we wouldn't get rid of it. That goes there. We run the brain on the party, and then that's it. That's the whole thing this piece of code would do. All of this becomes the default party brain. All of this becomes, well, this goes nowhere. This is just the stand-in brain. This gets replaced with the default character. Replace this with default character brain. So I think tile script operators, sure, but I think over in context H, that's where I would put something like helpers logging. Well, that's not really right. Operators, tile operators. Tool, Letarius, hello. It's going well. How are you? I'll put on a little background music for me. Okay. RPG as in a role-playing game. Yeah. I'll get to show off a little bit more of it as we're going here, but I'm kind of putting the last big building block of the system, which is the brain scripting layer. And once that's in there, if that gets in there today, we might get to start playing with it and building stuff. Although my goal is this time, instead of iterating on, game ideas, which is how I used it the first time I built it, I want to spend some time iterating on the architecture from the mistakes that I made the last time before I go too far with building something on top of it. Tile operators, character tile operators. So this here is going to be a part of the brain script operators when we're done. RPG use part of the brain scripting. But we're going to want these ones. So these will be brain, I'll call these like the brain run operators. So these are like function, void, RPG run, brain, RPG context, sim entity, done. Party default. I'm gonna just write down some of the pattern here. Character default. Brain script operators, brain run operators. So the way we're going to run a party default, we already had that marked off over here. That's this. So this is party default. You just go through each character and you do RPG run brain on the character. Okay. So that's not done yet, but then what we do is here we're just talking about going, there's going to be some kind of way to run an override brain. So if the entity has an override brain, you would run it. But then if it doesn't have an override brain, you do the default brain. So for now, this will just be run brain default context entity. And then I switch on the entity. Do I have entity kinds? I don't know if I actually have. Yeah, I don't. Okay. I'm going to go for a sec, and when I come back, we got to think about how this part's going to work. Because I've actually made the entities completely, like, pure Lego brick. There was no differentiation of kind even built in yet. That probably needs to change, and I need to think a little bit more carefully about this at some point. Let me double check. I've got a to-do list of... Okay, another thing I want to be able to do with an entity is... minimize the entity size. If that can be really small, then we can have lots and lots and lots of them stored in a log or save file or something, which will be interesting. Okay, one sec. Yeah, that's a 32-bit Boolean, and I only like going to sizes below 32 bits when I'm like intentionally packing a data structure. I kind of default to making everything 32 bits. Um, it probably really doesn't matter one way or the other. This is not something that I have like tons of. There's one of them sitting around. If I made that 1 byte, it would go right here and like, okay, so this could be one. This is a pointer, so that's 8 bytes anyway. So like, it makes no difference. This is 4 bytes right now. If that was 1 byte, either way, it's actually 8 bytes. It's like these. There's no point. Like here, I used 8 because I'm like, oh, there are 4 of these already. Let me pack them into one. Let me pack them in tighter because I've got them. But I usually just default to using 32s until, like for size stuff and hash stuff, certain things call for 64s, but anything that is just generic nonsense, I just go for 32 until compression and speed issues actually become the front of mind, you know? Okay, so I think what we need to do is pause on the brains. We need to go and build in an entity kind. It seems like. Right now we have entities for tiles, characters, and parties. Do I also make them for routes? I forget. Do I have route? No, I don't think we're constructing sim entities for routes yet. Okay, now whenever I construct a sim entity, I need to make sure that its kind is getting filled in. So let me see if I can go and find where these might be getting constructed. Okay, we're looking for instances of push, array. I don't have a way to like fuzzy search across multiple files. I wish I could say find me instances of push array containing the RPG sim entity, within the parentheses, But I don't have for coder, like reg expression features, so can't do it. Sim entity new. Parents not equal 0, do a little pushback. So one way I could do this is to say I just need to track down all the places where I'm using this function and make sure they all know how to get the kind in there. So we know that's a party, we know that's a character, we know that's a tile, we know that's a tile. So yeah, we could do this as RPG sim entity kind, and then we fill the kind no matter what. And then RPG sim entity kind on this side, and now compilation errors. Okay, what is this? I might have just made it so that it gets stuck in an infinite loop when it's running. Like, maybe the combat isn't working anymore, but all I did was... Did I not finish the brains? I didn't. Okay. Right, of course. Okay, so to make this work, so that it actually does something, this is just dispatch. Okay. Now if we leave it there, we should just get... There we go. Awesome. So now we've set up the brain run concept here, but we haven't actually done any brain scripting yet. This is still just a hard-coded brain script for every character. What I actually want to do is figure out how I want to attach brains to these entities. So the first main idea is the idea of attaching a default brain to each tile type. So if I have protected ID here, I want to be able to go get my game scripts and go write a brain script. For the protect tile. So this would be like RPG brain script for tile. Protect. So that's the symbol name for this symbol. That's the identifier it'll use to link to the protect tile script. Well, this creates a tile proto, and the tile proto is now going to have a brain script and a tile script. Something like that. So here, the logic is just use this. Now use is going to change when we're in a tile brain script for a tile. It's something like this. Like we don't need any parameters, because by the time we reach this, the question is just how are we going to decide whether or not to use this. And then this context is going to know the tile and the character. At that point. But we could just say like we're gonna have to grab these from default and always go through this factorization. It's a little bit more verbose. Yeah, a lot of people say that. I don't know why. It seems like they're all the same to me. Like you could make this. 4 is like the max size that I can read, but um, yeah, it's just a matter of doing it for a couple days in my experience, and then it becomes totally normal and feels way better. Look at all the code you can fit on the screen. All right. Okay, so we're gonna need something like this character, this tile ID, something like that. I need to work out these things even better because this is clearly going to be related to the one for the tile scripts. Give me 1 sec. Okay. Okay. Scripting. RPG brain script for tile, symbol, name, hook signature, RPG, symbol, tile brain script. Register. Brain. Tile. Brain tile script. Yeah, I don't do anything to help with visualizing the large structure here. Like I do love stuff that has the vertical line here to show you like when I'm looking at this that could show you what the top like, oh, we're in the script for this or whatever. That makes sense. Gabriel, thanks. An RPG simulator is like, you know what an RPG like a computer game is like, right? With one or more players, you have an RPG game. A simulation in a game, the only difference is that a simulation is a zero-player game, right? It's like they work the same way though. So I'm making an RPG simulator, as in the system isn't set up to play it with it like it's a game. You just set up characters and scenarios and then simulate them, and you can use this to like gather stats on how different compositions of parties and challenges go against each other. And I made one in like a 6 week, just sort of like for fun. I started programming with it and started having a lot of fun with it, and that was back in December. And so I'm rewriting it now because it kind of got to the point where there was just nothing left that I could. I just wanted to go so much farther than what I could do with the like hack together architecture. So now I'm trying to build the architecture thoughtfully, one step at a time, and take notes about what needs to be improved as I go. But I can run the old one for you. So let's see if we run the old one. It's going to run in this run panel for a little while. It's slow because it's simulating a lot of scenarios, and then I can show you what the kind of stuff I was pulling out of the simulator before. Okay, so right, I'm gonna run into this issue of the scripting operators again. And I want to write that one down now that we're hitting it. So there's some kind of problem. Right on the surface here. Problems for scripting. Many candidates for operators. I don't want to say something like contextually valid in complex ways. How to wrangle these questions. Okay. Let's see. I can probably show you the. Yeah, here it's done. So, if you're still here, Gabriel, here's the old version of the simulator, what it looked like. And for anyone else who hasn't seen it yet. So what's happened here is each column in this table is a separate adventure party. See, I've got this one's like a mix of different characters. The farmers are just basic characters with no special abilities. They're like the benchmark. And mercenaries another nice benchmark, but a little bit better. They have an ability, but their ability works best when they all work together. And it's not very useful when you mix it with other character types. So you can see that like I can put in on the left here we have this list of different routes or roads, and it's basically a deck of encounters. So here I've generated these encounters with these little strings. So like where there are zeros, it looks a little funny because why am I writing the zero? But that's just because I generated every combination of 6 cards for this deck from these 3 different types of encounters. And then that gets shuffled. The party goes against them. Little bot brains decide what moves get made along the way. And then it runs like 10,000 it runs that one scenario about 10,000 times and creates this much information from that, right? So if I put in one road in one party, I get out one of these, which tells me that typically one character died out of this party when it went in against this challenge. So this is a difficult challenge because it was killing at least one, even against the really good party. And I can kind of see how much variance there is. There are times like right here we can see it's taking about 1.5, but there's not that much variance. It's like it's either 1 or 2. It's not sometimes 0. It's not sometimes 3. It doesn't look like this is very narrow spread. And we can see that narrow spread is still the same here and here. So what is this challenge? 6 of these guys creates a very, very narrow range of possibilities, whereas 4 of these and 2 of these apparently creates a wide amount of variation. Like it can be very deadly or it can be very safe. And so the point is, as I'm able to build the simulator better and better, hopefully I can get to the point where I can look at these and use them as guidance on how to actually craft a difficulty curve that I want to craft intentionally. I feel like that'd be very cool to be able to just construct your difficulty curve. And if that's possible, then maybe it can also be generated. So Seven Artists asked a really great question. How do you tell if the bot played the encounter reasonably? So what I just showed you was the statistical mode, and you can see the distribution of random events. But if you want to see how they're playing, you have to drop down into log mode and look at the full log of a certain run. And so I can use that to do things like debugging that the bot brain is behaving roughly the way I expect, and also the tile effects. So the RPG is programmed out of characters that have tiles on them, and the tiles basically give them all their abilities, their status effects, and the old simulation was even included their inventory items, everything. And the reason I say in the old one is I haven't decided yet how items are going to work. There's kind of a paradox in the engine of the first one that I'm not quite happy with and haven't resolved yet for the second engine. But point is, I can debug whether the tiles are behaving the way they should when they get activated, and then it would then on top of that have the effects of the brain scripts. Now, to answer your question, you're asking, wouldn't it be a lot of noise if it's random moves each turn? It's not exactly random moves. There are brain scripts which determine, which you can use to craft optimal strategies. So, for instance, if a character can do one of 2 things, they can attack or they can taunt to draw attacks to them. Or we could say they attack every turn. So the captain character could attack every turn, but could optionally do a taunt, which would cause all of the hits to come to them instead of to anyone else in the party. And they could do that as many times as they wanted. So it's not exactly random, but there are random events within the system, right? And there are times where it's not like if you just mash a couple abilities together, there's no automatic way to make at least I don't have an automatic way to develop an extremely high quality AI for that one combination of abilities, and also for that one combination of enemies to encounter. So instead, what I'm focusing on is being able to craft or sort of draft up those difficulty curves in simple cases. In order to make the leap into more complex cases like what you're talking about, I'm going to need to be able to solve the AI problem a little better. And I don't know if I want to go that direction or if I want to go in the direction of making a human usable interface and testing out the difficulty the old-fashioned way. But I want to see if I can correlate subjective difficulty for a human player with anything in the data once I've got the simulator up and running. Because if I could, then I could use the simulator to sort of scout ahead lots of possibilities and find things that look like they will be the right kind of difficulty more rapidly than what you can do if you have to, like, you know, build it into your game at each step. And of course, this is still early days. I'm just trying to get the first layer of tile scripting and brain scripting up and running. Other stuff that I want to be able to do with the simulator, I'm not even talking about yet. But like, I want to be able to have. I have a lot of ambitions for other things we can throw into this so that you can craft little RPG worlds and program them in interesting ways to test out ideas and see what happens. I don't know why, but it just feels like a ton of fun to work with. Hey, a bunch of folks just said hello. Welcome, everybody. All right, so I think where I was leaving off is, yeah, I need to just implement these guys right now. So there's a big question mark over how I should organize this kind of thing, because these are definitely tile specific. These could be tile brain related. This could be brain related or tile related. This is tile only. These aren't even script operators like this is, but these two aren't. So none of this is organized. Okay. For now, I'm just going to throw in the things that the script calls for. RPG, this character, context, function RPG U32, RPG, this tile ID, RPG context. But this character doesn't actually work in the tile scripting case. Yeah, it's confusing and weird, and I need to get a handle on it. Ugh. Oh, great. Okay, say again, what's the problem? Oh, that sucks. Okay. Tile brain script. Okay, so apparently my reg system, I didn't know what I was doing when I first designed it. This is the way it actually goes. Yes, we are missing the function header. That needs to go there. Okay, and we did that because then we can go simple tile script, RPG reg data kind tile. N. Okay. Tile brain script. Tile brain done. Okay. Okay, so that's how you write the brain. How do we want to use that? That gets how do I want to think about this? So this is a tile brain, which means it can be attached to a tile, and we've named it protect to say that it should attach there. I think that's the right way to do it because, well, I guess the part where that could suck is if there are multiple ways, if there are multiple strategies that you want to encode for how to use the tile, but one of them has to be the default. The others would be for swapping in, so maybe it's still fine to have the name correlation be the method of putting them together. So I think it goes and lives on the proto, although I'm not sure. Right, we could have an RPG hook brain, which is just something anybody can have in their proto. And so when we build a proto tile, we'll attach the brain from this if the tile name matches, right? If we get a proto with a name, and then later we'll go through the tile brains and associate some of them into the protos after the fact. Tile brain. We look through the reg data, grab the hook. This time we're not trying to run the hook. What we're trying to do is see we want to go back to the context. Right, we're just going to do proto ID equals RPG ID from name. So we've already created all the tile protos. We're just going to go, hey, do we have a tile, like a proto ID for the name on this, right? If the ID is not 0, why don't we just go, we can just do this all the way through. So we get the proto as a pointer so that we can modify it. Now, if the proto is already RPG proto kind tile, then we're going to go set the brain of that proto to the hook. Do I navigate with arrow keys? Yeah, I navigate with arrow keys, although I also use like long jumps, like Control and Alt to move fast. And then I use a lot of home and end and Control up and Control down and that kind of stuff. Okay, so that should have stuck some brains into a brain into one of the tiles here. The protect tile should have a tile brain in it. Um, we can stop doing this part. Okay, so what happens next? The tile brain is there. We want to go and write how the tile brain gets used, which is we go to the default brain. We're going to rewrite it. So now what we're going to do is take the tiles we've got and iterate them. Node is going to be tile. Character is going to be first child, like that. Where is this game scripts? I want to add another one, like just like this, for the attack tile. So these brain scripts aren't fancy at all. They just say if you have this tile, use it, and you can actually only use one of them. So whichever one comes first will win. We're going to solve that problem another step. RPG proto equals RPG proto from ID, context tile proto ID. If proto brain does not equal 0, run the proto brain. Of course, in order to start running brains, we need to fill in some of these scripting registers to set up the context. So let's see, this tile is this one. Set that and unset it. We can just unset that at the end. This character is this one. Whoops. All right, so the protected status is getting assigned, which means this guy is still using his protect tile, and we can see... Well, this is weird. It looks like they took 4 damage. But then how did he do this? There's no limiter on how many moves they can make yet. So the way the brain scripts work is they just say, under these circumstances, do you use this, yes or no? And then those are tile scripts. So if you want to put together a smarter character, you can put together a character who will then use their abilities in ways that make sense. But then that character brain is now tied to that cluster of abilities, right? If you take one of them out and put something else in, the brain isn't adaptive, right? These aren't adaptive plastic brains. They don't learn. So the remaining piece is to be able to build like not adaptive brains. The remaining piece is to be able to have these like order themselves in a way that makes sense, so that you can just build brains by smashing together abilities and tile scripts. But in order for that to work, what I want to do is phrase it as each one runs as if it ran first, and if it did go first, it works. If it went later, it loses. Like, it does not, like, multiple attempts to use abilities get ignored after you've used up your move for the turn. So that whether you use one strategy or another comes down to how they get sorted. And that also means that the logic of limiting these is built in at a layer deeper than the brain. So a brain can't be misprogrammed in order to get a superpower. Brain is just like trying to hit a button, but the engine is deciding whether that button does anything or not separately. Seven artists, I'm not sure I totally understand your question. What would adding weight to it mean? It sounds like you're trying to think of some way to write an AI system that can classify the abilities so that their usefulness appear like is stronger or weaker in different cases. Like, you could imagine a system where you have a bunch of abilities, and each ability knows how to score itself in terms of how strong it is, and then whichever one has the highest score goes, or maybe it's like you take a random move weighted by the scores of each ability, something like that. I could imagine a bunch of different ways to build something like that, although that's not exactly what I'm going for. I need a little bit more time to unpack that, but I want to answer Izoma's question. Yeah, so let's talk about how I'm using these quote-unquote scripts. So I talked about this yesterday. They're not scripts as in outside of C. They're still compiled C functions. So what's happening is I'm using a couple of tricks. First trick is you got to know how to do declarative stuff, and I've got this buried in so many layers of macros it's a little hard to follow. So I've got this before main macro. You're going to want this in order to do what I'm doing. So you need something that lets you say, I'm making a function that runs before main, and I have an article about how I do this. If you want, I can link it to you in the chat. But once you can say, hey, I want this particular function to run before main, then you can start coding stuff like this. Here's my main, and usually you have to go and do like, register, we'll call it RPG register context, and then you'd have like your hearts tile and your RPG heart tile script or whatever, right? And then attack tile script, protect tile script, right? You'd have to do this, and then you could imagine from there that the macros here are just a fancy way, they would just look like this, and so this would just like RPG attack tile script would be like, okay, so the tile script macros would just look like this, and it's just a function signature. It's like, here's the function header, here's the function body, and then you manually register it. The trick is I'm doing both at the same time, right? This macro is associating this symbol name, this symbol name, RPG underscore underscore attack underscore underscore tile script, with this function body. So it's using the macro to expand that to the full name and put it in a function signature. But then it's also using the macro to register that function pointer with that string in a before main function. Does that make sense? So before main runs, all of these pairs go off. And so my registration system lets me say, okay, before main, I want to be able to take, I have this little body here. So before main just takes a function name, and it's like a function that takes in a void parameter and returns void. So no inputs, no outputs. It's just side effects. And the cool part is it runs before the main entry point. So you can put it anywhere, and it'll do that. And so then it calls my register function, and the register function is basically just what I showed you plus more. It's like a name, a kind, a value string, and a function pointer or any kind of pointer gets associated together. And then those just get sort of chained together into a initialization data structure. At the beginning here, I make the reg map, and that takes the the loose data structure, which is just a bunch of these reg data things, and condenses them down into a hash map, which is keyed on the kind and the name. So I can use a kind and a name to find one quickly that way, or I can get the array of each one. So it's like a nice packed data structure at the end that I can use. And then I use the reg data to go and initialize all my other static stuff. So anything that I want to do that's sort of object-oriented-y in C, I can now do it by just saying, okay, we don't have objects per se, but we have functions, which are actually better than objects, because instead of saying I'm going to declare this object and then I still have to go and construct it somewhere and insert it into a list to make it work, it just automatically associates this string with this function in your reg data, and then you can process that data however you want to stitch together more complex data structures over here in main. Hope that helped. Bustronic, the function macro just stands for static most of the time. Yeah, so the main reasons I've noticed I haven't gone that far is because I just haven't been too serious yet about making the brains adaptable. It would be useful to do that so you can just throw together abilities and get a decent behavior, but I think in order to really test it out, what you'd want to do is you'd need to be able to visualize how that decision making is happening. The more complex the decision making gets, the harder it'll be to tell if it's actually falling into some really stupid behaviors that are driven by a heuristic. Like that sort of heuristic programming is not always as easy as you might think. So I've been hesitant to go there, and instead just intentionally looking at how is this party behaving. Oh, they're wasting this resource. Let me code up a slightly smarter brain for this party so that I can test out what I really expect them to do against this challenge or whatever. The handcrafted brains aren't reusable, obviously, but they do let me, having the ability to have a handcrafted brain is a good baseline problem to solve. Having one default brain and relying on it might sort of atrophy the ability to script up specific brains that solve for specific scenarios so that you can test out how those work out. Hopefully that idea makes sense. But if I got to the point where I could easily mash together abilities and scenarios rapidly, and I was getting sick of having the brains be so bad, I think an adaptable brain project would be a good sub-project of this whole thing. Yeah, so half of what I explained is not in the article, and half of the article is about other stuff, but it's here in this dynamic linking article. So I went through in this article and worked out a couple of things I needed to get across compilers and across operating systems and stuff, but the last chunk here is there's the invocations for it, and then I guess the other part you would want to look at is the code. Dynamic linking example, right. So if you come in here and you look at this will explain a little bit about how I designed the system. It's a mix of how to deal with dynamic linking, so having a DLL and an EXE come together when you have a base layer. So I'm trying to build my base layer to support dynamically linked programs. And that always supported them, but to support them better with like a control over whether or not you unify the log between the EXE and the DLL. Usually you want to unify them, but that wasn't the way my old layer worked. But then the before main stuff is just sitting right here in a nice tidy example by itself. So you can see how before main works. And once you have before main and you do a little bit of refinement on it with a macro, you figure out the rest. Yeah, I don't do that quite that way anymore. I just call them all global. Like the local is even more confusing to me because a local variable is one that is local to the frame. And really local statics are just globals with a narrow domain of interaction with the whole program, right? They're not non-global though. It's much more reasonable to think, to me, to organize local statics and global statics into the same space in my mind, and that the only difference is namespacing. Which isn't really an issue of global or local, it's an issue of just how things link to each other. But the difference between a static global and an external global is another layer of distinction that I don't name that way. I think of, let's see. So I know I've got macros for extern variables these days. Those aren't mine. I might have to go look at this Mr. Fourth Base keywords. So yeah, I've got global variable is this. It's compile time global, meaning static. And then I call the linked global variable if it links across object files. Okay. Okay, yeah, so that's everything. I think this is a good spot for me to stop. I've only been up live for about an hour, but that was actually a pretty good first step. The next steps here, let me take some notes And then I'm going to wind down until maybe like 3 or 4 p.m. today. So maybe about 3 or 4 hours from now, I'll get on and do some more work. But that's it for sketching out the simulation system. And some problems that are going to come up for brain scripting that I want to think about how to solve. That I haven't already covered in the general case. So some issues are sometimes the brain scripts need to do things other than use tiles. Decision types other than using tiles. Buzztronics, yeah, I do think that there are issues with C, but the other thing is like, it's pretty close to good enough, and I constantly find, I haven't looked at hair, to be fair. With Zig, when I've read Zig code and worked with it, I get the slight impression that it's more complicated than what I want. I've been in a conversation for, a long ongoing conversation about like Zig comp time versus metaprogramming for a few years, and I'm still not convinced that I get why you would build all this stuff into the language. It just seems like you're making the compiler so much harder to build. I like the idea of a C-like, so if I was going to switch to a C-like, I think Odin is the one I'm possibly most curious about. Although even that might be a little fancier than what I'm looking for. I might go as simple as just saying like I want something like Ion. I don't know if you've seen. Whoops, not IO, Ion. Bonson with an E. Got it. So yeah, if you look at here and this project, the language described, I guess it's not really, I don't know if there are, this one is just, at least the way Pear described it at the time, is this just C, no new major semantical differences, but a bunch of simple quality of life stuff like better member accessors, out of order support for out of order declarations of functions and structs, better in place literals, just like all the things that you would do to make it a little more flexible to do stuff with it and a little less verbose. And that's kind of like what I want. And yeah, that's the other piece of it, is that there's a lot of investment to learning a new language. And I get pretty far with C, even though it is difficult. Maybe this is what I want. Although, I don't know. That looks like C++ inspired syntax. I'm not sure how far it's going to go in that direction. structs, tuples, tagged unions, slices, strings, functions, type aliases. Okay, that's pretty lightweight, not very oopy. Okay, this could be cool. I'm not sure. There's some things here that are a little, it feels very like Unix philosophy, you know what I mean? Project directories and folder module folders, and then makefile architecture plans. You know what's missing though? They're always missing this. Does it have yeah, so something is missing that I think, and I'm not sure if anybody has this. I think maybe JAI has this, but then it exposes it through the event loop, which may not be my favorite way to do it. But um, it just like, where's the ability to tag things so that you can so that you can um it just seems to me like you should all these languages should have the ability to shift towards declarative programming. Like all the stuff I'm doing with C declarative programming here is still not. That way you're not always required to handwrite runtime code to wrangle and construct associations between code and data. And yeah, I agree with Paging Turner too. Each language is it's always such a closed ecosystem, and if we shifted our attention in a different direction and we built open languages and a really great composition environment, uh, um, I think we'd be headed in a better direction in terms of how much we can do as individual programmers. All right, let me think. Were there other things that brain scripts needed to be able to do that got complicated? I still need to be able to do brain types versus brain associations. Party level brain on character proto. Yeah, Buzztronics saying we have back ends, and the context being, I'm saying we'd be in a better place if we could uh, have less closed language ecosystems and more sort of open, composable ecosystems. And the thing with backends is that they're all so um, none of these things ever have an interface that indicates that the intention is for you to use this daily, right? I mean, we designed them with such um, intensely complicated interfaces that we then have to automate the driving of those interfaces. So we get like systems with APIs and complex command systems for executing and passing files from one process to the next that are so uh, annoying to work with that we don't do them by hand and we don't see them happen. We write scripts to deal with them, or we write more code that runs the APIs or whatever. Uh, but what we actually want to get to is a place where moving files around and moving windows around on the screen is the language of arranging and executing compositions of tools and uh, workflows in general. Which means that the tools that are going to work in that environment need to create interfaces that are designed to be used daily, and then that environment needs to provide ways to transition from interface use to automation. Anyway, I'm gonna wrap up for now. I'm gonna go get some lunch. I'll be back around 3 or 4 p.m., somewhere in that range, which is 3 or 4 hours from now. And we'll keep making progress on the simulator. I'm not sure where yet, but on some edge of it. All right. See you later.